Okay, so here we have a problem where we have um, uh, a speaker attached to a base, which is attached to a spring, moving back and forth to an observer, which at its maximum point, the observer is 1 meter away from the speaker. We need to find the highest and the lowest frequency at which the observer hears the sound, and the decibels at which the speaker is as far as possible from the observer. So we know that we need to find the velocity at which the mass is moving. So we need to find the conservation of energy. We know x, which is 0.5, is the distance of compression of the spring. The mass, we know it. Also we know k, and we don't know the velocity. So after isolating, we know that the velocity is equal to 1 meter over second. Then we need to apply the Doppler effect. So we know that the Doppler effect is given by this formula.
Yeah.
This frequency, f prime, is what we don't know, but we know the frequency at which the sound is being emitted. So f prime is going to be 440 hertz times, for the first case, 43 meters over second, which is the speed of sound, over 343 plus 1, because the speaker is moving away. And after this, we know that f prime is equal to 448 hertz, and this is the minimum. Now for the second case, is f prime is equal to 440 times 343 plus 0, because the observer isn't moving, and 343 minus 1, because the speaker is moving towards the speaker. So the f prime is going to be the maximum of 441.28 hertz. That is the end for this part of the problem. For the second part, we need to find the intensity at which at its maximum. So we know that the Vmax is 60 decibels. It's given by the problem at a radius of 1. The radius is because here, at which it's maximum, the speaker is at a distance of 1 meter. So if it is at 1 meter and the spring is 0.5 meters away from the wall, after it moves away, it's going to be the radius 2 meters. So for the second case, the minimum is what we're trying to find, but the radius is equal to 2. So we need to find the intensity at this point with this formula. B is equal to 10 log of I over I naught. We know I naught, we know the B, and we don't know I. And after isolating, we know that I is equal to 1 times 10 to the minus 6 watts over meter squared. Now we need to get the power at this intensity. So as the power is propounded in a linear way, it's the same here when the speaker is as near as possible to the speaker and when it's as far as possible. So we need to isolate the power from here. And after isolating power, we know R, we know the I here, and the power is equal to 1.25 times 10 to the minus 5 watts. And then we need to apply this power to find the second I. So we need to apply the same formula, but to a radius of 2. It's 4 pi of radius, which in this case is going to be 2 squared. And the second intensity is going to be 2.48 times 10 to the minus 7 watts over meter squared. Now we can get the maximum decibels, because this is the intensity. The lower intensity, it's going to the lowest intensity, this is going to here, so we need to apply the second formula again, which is V equal 10 log of I over I naught, and I is what we just found here. It's going to be V is equal 10 log of 2.48 times 10 to the minus 7 over 1 times 10 to the minus 12, which is I naught, which we know already. And V2 is going to be of 53 decibels. And that's the end of the problem.
Güey, no lo borres, güey.